Hi, everyone, and welcome. My name is Ryan Keenan, and I'm the Director of Product here at deeplearning.ai. We really appreciate you taking some time for this event today, and we hope that you and all your families are doing well. These have been difficult times for the last several months. We know that wherever you are in the world, and we have something like people joining us from something like over 140 countries today, we know that wherever you are in the world, it's been a difficult several months and it's not over yet. So we hope that you're doing well, and we hope that maybe you've had something good come out of this, like more time with family or a new opportunity or something else. But today we are gathered to celebrate the launch of our third course in the natural language processing specialization. And we've assembled a panel of experts to talk about NLP, about the work that they're doing, about the future of the field, and give some perspectives. So NLP is really all about giving machines the ability to interpret and manipulate human language. And so as all sorts of different fields in AI continue to expand and make significant contributions to industry, the demand for people with skills in these areas is only growing. So we're really excited today to launch this course. Our mission at deeplearning.ai is to create great courses, really, and to make world-class AI education accessible to everyone. So our goal is really to empower our community of developers and business leaders and people changing their career paths, all of you, to be part of this AI transformation that's happening all over the world. So these courses are created by experts from industry and academia. And course 3 is sequence models in NLP. It just went live a few hours ago. And so this is a really exciting course in the sense that with courses 1 and 2, the skills that you built, if you were a learner in those courses, were sort of foundational skills, the NLP basic toolkit. And then now with this course, you're moving into more sort of real world applications, so more powerful models and applications. So super exciting course. And today's panel of experts that we've lined up have a lot of interesting input on the field and on all these different techniques in NLP. We've also lined up a sneak peek of the courses, and we'll have a course demo at the end, so stick around for that. Today, our agenda will be opening up with a keynote by Kaiser, who's one of the instructors in the NLP courses, as well as a scientist at Google Brain. Following that, we'll have a talk by Andrew Ng, who's the founder of Deep Learning and deeplearning.ai. And then we'll have a panel discussion where we'll bring in addition to Łukasz and Andrew, we'll be joined by Kenneth from Baidu, USA, Professor Marty Hurst from UC Berkeley, and Eunice Mori from Stanford, who's also one of the instructors in the NLP course. After that, we'll do a Q&A session, and we'll select, we'll do a panel discussion, and then we'll have a Q&A session where we select some of the most upvoted questions from our NLP Learner Slack community, which is the Slack community you can join once you enroll in the specialization on Coursera. We've got several thousand of you in there already. And then following all that, we'll do the course 3 demo. So without further ado, I'd like to welcome our first speaker, Kaiser, who's, as I said, one of the instructors in our NLP specialization. Łukasz is the co-author of TensorFlow, as well as the Tensor to Tensor and Trax libraries. And he's a co-author of the Transformer paper, which has really transformed the field of NLP and deep learning in general. He's a staff research scientist at Google Brain, as I mentioned. And so it's a great honor and a pleasure to welcome you to this forum today. Łukasz, I'll turn it over to you now.
Thank you very much, Ryan. It's great to be able to see you, and I want to tell you a little bit about how I came to deep learning in NLP. And launching this course is a very personal thing for me as well, because I've been working for the last number of years on using deep learning in NLP and making it accessible to people. And it's been a wild journey. So we started the work, around the year 2014. People in the NLP community did not believe very much in deep learning. Of course, not all of them. Some did, but many did not, because the best performing methods were still not deep learning based. They were based on probabilistic models. You've learned about them in the earlier courses, and they gave good results. For example, machine translation, which is the field I've been working on, mostly was the performance there is measured by something called the BLUE score, and it's the higher the better. And around the year 2013-14, the best BLUE score was obtained by phrase-based systems. And on this English-German benchmark, which is a standard data set, it was about 21, and it was considered quite good. But for comparison, like human translators score would be around 30. And people were thinking, okay, these deep learning systems that came around then, they were maybe got 19, maybe managed to get 20, but they were very large. And we managed to train just larger networks. And these networks, you will learn about LSTMs in the course, they're not complicated, but the larger you make them, the better they work. And around 2016, they got really large and really good. We got 25 BLUE, which is when the Google Translate launched a neural network for translation for the first time. It was a big thing. It really improved performance for the first time over the old methods. It was still 25 BLUE, and training this model took about a month on 128 GPUs. It was absolutely not reproducible outside of Google. No one could do this because it was very tied to Google-specific hardware. It was a special framework, but it worked. So RNNs started spreading into NLP. And as you learn in this course, the RNNs work by processing the input word by word and then decoding the output in another language like this. So RNNs are great, but as I told you, it's slow. It takes hundreds of GPUs. And also when the sentences get long, when you go beyond one sentence to paragraphs, the gradients don't propagate that well. And then in 2017, we had this model called Transformer, which does away with the recurrence in RNN. So it's way more parallel. It can use way less compute. And it gets BLUE scores on the order, in the paper it was 28, then if you train longer, you get it to 29. With some improvements now, we actually got it to 30. So on the BLUE score metric, it's on par with human translators. So that's what you learn in course 4. And the transformer model is deceptively simple because it has no recurrence. It has this attention matrix that attends everywhere. And it turns out it works not just for translation. It works for a large number of NLP tasks. I'm sorry to
interrupt you, Łukasz. I'm sorry to interrupt. Yeah. I just noticed your camera is off. Would you be willing to turn your camera on so folks can see it as well?
Sure. Sorry, I didn't notice that it got turned off. So yes, that's the transformer model, and since it does better with gradients in long sequences, and to understand why it does better with long sequences, you really need to understand RNNs and then look at attention. So that's why it's a really good idea to pay attention in course 3, understand the RNNs with their features and problems, and then go to course 4. And with the attention mechanism, you can generate a really long text. So this is the text generated from the OpenAI transformer. The thing in green is the only thing you input. It's a prefix, and then it continues the story. And it really reads like you could have written the story, which 5 years ago was something in the field of NLP you would barely believe that a model can be generating coherent stories. So what are the frontiers? Well, we are going into longer and longer sequences. We are getting models that are more able to reason. We're getting models that can do few-shot learning. There is now a GPT-3 model that does few-shot learning. And there are more and more use cases for these models. So it's not just translation these days. It's a lot of NLP tasks, generation. It's also language to programming. There are a lot of exciting developments still going on, but the basics you learn in these courses. So join them, learn about them. And these days, luckily, you can train your models in either a Google Colab or even just on your own computer. I find this very exciting that you can train a whole translation model in your own environment rather than on hundreds of GPUs, and we can really explain to you every detail of how it works. I hope you will like it too. Thank you, Ryan.
Thank you, Łukasz. That's fantastic and super interesting how it seems like bigger and bigger models have been sort of the path towards better and better outcomes, but then at the same time making those models faster and faster so that they can be not just big and slow and only runnable at Google, but big and fast is super cool. I like how you emphasize too that understanding the basics of some of these building blocks like RNNs is really important to getting to the big complicated models. I hope we can talk more about that in the panel discussion. But right now, I'd like to turn it over to Andrew Ng, founder of deeplearning.ai, and get his perspective on NLP and where the field's going. Over to you, Andrew.
Thanks, Ryan. Hey, everyone. It's nice to see you here online, despite the circumstances of the world, and thank you for joining us. What I want to do is share with you some thoughts on the state of NLP today. And I know that many of you are looking into breaking into NLP, hence the name of this session that we're holding today. But what I thought might be useful would be if I share some thoughts on where I think NLP is. So the rise of AI, the rise of the deep learning revolution, the rise of machine learning and AI is leading to more specialization into subfields. I feel like my background is a machine learning generalist, but as the field matures, there are now more and more specialized tools in the most important application sectors of AI. And this includes, of course, NLP, with lots of specialized tools that grew up and are native to NLP, like some of the things that Łukasz talked about, but some of which, like transformers, which had its roots as NLP, but is now breaking into other sectors as well. And then also, of course, computer vision, speech, audio processing, a lot of exciting work on structured data that's not widely appreciated in some of the published literature, I think. And then other sectors, everything from medical imaging to robotics to earth sciences. All of these different subdisciplines are building up specialized tools to take advantage of the deep learning revolution. Just now, Łukasz alluded to the history of the growth of deep learning and NLP. And I thought I want to share with you some of the history that I saw for that, because that has implications for some of the work that all of us do, maybe some of the work that you might end up doing today. So the rise of deep learning, we all know about that. What happened from where I was sitting? What I saw was that deep learning as an application discipline first had its biggest impact in speech recognition. So I remember it was about 10 years ago, maybe around 2010, the work of Deng Li and Jeff Hinton and a few others really showed that deep learning can make a big difference in speech recognition accuracy. And what happened, and I was leading a Google Brain team around that time, reading a lot of these papers and implementing these algorithms. But this first wave of the injection of deep learning to speech recognition resulted in dramatically improved speech recognition system accuracy and a wave of new applications, everything from the smart speakers to voice assistants to practical voice search that you use on your mobile phone maybe. And the injection of deep learning to speech improved accuracy and led to a wave of applications. I think the second wave was computer vision, where, again, this well told, the story of 2012 ImageNet, AlexNet, and that in turn subsequently led to a slightly later wave, but equally big, or maybe even bigger, I don't know, wave of new applications in computer vision. And so, everything from today, some of my teams are inspecting things in factories using computer vision, or there are teams driving big machines using computer vision, or computer vision is enabling driver assistance systems, maybe in a car that you drive or will soon drive, even if we aren't all the way to complete, self-driving cars in all the ways we hope to get to someday. But of course, face recognition with all the problems and opportunities that creates too. But that's a huge wave of applications. And then I think NLP, as Łukasz was alluding just now, came a little bit later. And I actually remember when deep learning first hit speech recognition, the community had a lot of internal angst. We had spent all this time hand-engineering features. What are we doing? Will this work? And then the field of computer vision had the same controversy and angst and discussions. And then I remember when my friends in NLP, were going through the same thing, and deep learning guys, right, were saying, look, got to use deep learning. But the people that spent a long time in other techniques, it was a journey of transition. But I think because NLP had the wave of deep learning had hit NLP later, this rise of increase in accuracy came a bit later in NLP than speech or computer vision. And so I think there is actually a very large set of untapped opportunities in NLP, as in today we have very good speech recognition applications with still lots of opportunities, with quite a lot of vision applications. But I think the set of untapped opportunities in NLP is just massive, because the wave of improved accuracy has come relatively later, and there's still so many applications that this opens up that no one has really thought of yet or invented. So to those of you thinking of jumping in NLP, I think this is actually a very good time. It's not a bad time to do vision or speech recognition either, but the space of untapped opportunities in NLP feels huge to me. And then, of course, in the history of deep learning, there's still these other disciplines that are still jumping in and enjoying these improvements in performance, which are also leading to improvements in lots of applications. So today, NLP has tremendous momentum behind it. Here's a market study. I tend to take these things with a grain of salt, but significant rises in the value of NLP applications are projected by this organization, Tractica. These numbers, frankly, seem low to me, but I find the trend useful as a confirmatory trend. And if you look at the growth of ACL and a big NLP conference, number of submissions is rising rapidly. So the volume of activity very much seems up and to the right, and maybe even accelerating for NLP. And what's exciting about all this? One of the magical pieces of NLP is that today, probably all of you use NLP dozens of times a day without even thinking about it. And the applications that work so well, they've disappeared in the background. You don't think of them as NLP anymore. It's just something you use every day without thinking about it. So today, most of us use web search probably every day. And we talk about search. Web search is the obvious one, but lots of websites have product search capabilities. Go to the website, maybe buying something, looking for a movie, looking to buy something for your home. Search is not just the web search engines. It's actually pervasive on a lot of apps and websites. Summarization. When you do a web search, that snippet of text is really valuable. Autocomplete, again, in search functionalities and how we type, useful all over the place. Anti-spam without anti-spam, our email system just won't function. Machine translation is actually getting really good. It's interesting that, and we'll see. Hopefully, the world becomes a place where anyone can talk to anyone else, even if we don't understand the same language. But I find that very exciting. Smart speakers, smart assistants, in addition to speech recognition portion of it, there's an important piece to understand the words you actually said and translate that to action or command. And nascent chatbots. There was a wave of hype in chatbots. I think the hype around chatbots has died down, but there are actually working chatbots today that provide real value, even though the hype isn't quite there. But some of these are today's NLP applications, many of which still have significant room for improvements or significant room for reinvention. And if you learn about NLP, I hope that these will be, some of these could be sectors. Maybe some of you could dive in to build cool stuff to move your company or to move the world forward. And one thing that excites me at least as much, maybe even more, is all of the future applications that none of us have even envisioned yet. I don't know what the future applications will be, but these are some that I personally find exciting. I'm just one person. Some of you, maybe you have better ideas than I do. I'm personally excited about the application of NLP to education, specifically to auto-grading, giving feedback to people at scale. I think there's a lot of room for improvement in email tools. I know email feels like it's mature, relatively consolidated industry, but with the rise of modern NLP, and I think Google's Smart Reply, right? The but when you hit a button and get a reply back, that's just one small piece. I think there's actually a lot of room where sometimes I ask my collaborators to help me deal with emails. Some of the things I ask my collaborators to help me with, I think could be automated. So a lot of room for improvement. Synthesizing academic papers. There is research on this, but I'm actually excited about, there's so much literature in many disciplines, like medical discipline. No human can read even a small fraction of these papers, but I think there's actually a lot of, I'm seeing nascent progress. I'm seeing weak signals that this could become a big thing in terms of spotting trends in a statistical way from this giant body of literature to help us drive medical research or maybe even medical decision-making in a heuristic way sometimes. RPA, robotic process automation, has been taking off rapidly. Lots of great companies doing RPA, and I think there's a potential for NLP to make RPA, robotic process automation, much more flexible, and many more. The ... is really, I would love if a few years from now, I'm giving another talk and maybe something that you come up with ends up what I could talk about and cite you, in the ... some idea that none of us, that I certainly have not yet thought of today. So the rise of NLP's accuracy opens up tons of rooms, both to improve today's applications, which are already important and pervasive, and also to envision new things that just were not possible before. And on the research front, I want to highlight one, which is just one other thing I'm excited about. And if you complete the NLP specialization, all the courses, you'd be well positioned to jump into, to try your hand at some of these cutting edge aspects. You may have heard, a bunch of us, right? Me, Jan Kuhn, Jeff Hinton, also Yosha, chat about the importance of unsupervised learning. Well, there's one aspect of unsupervised learning that I'm excited about that isn't like a 30-year-off thing, but it's something that's working now. Well, I say about 10 plus years ago, I think it was actually like 12, 13 years ago, I started getting excited about one application of unsupervised learning that we call self-taught learning. And here's the idea. You want to learn from a large amount of unlabeled data. The world has a lot more unlabeled data than labeled data, be it unlabeled images, unlabeled text, So learn from tons of unlabeled data. And this thought was motivated also by the observation that most of human learning is from unlabeled data, right? So some of you know I have an 18-month-year-old daughter called Nova, and I love her, but I'm not going to point out one object to her every second to her life. So frankly, I do my best to teach my daughter, but most of what any son or daughter, any infant learns is just wandering around by themselves with a little bit of supervision maybe. But so we think most of human learning, human infant learning is unsupervised. So computer algorithms learn from tons of unlabeled data. And then the self-taught learning task is to take what you've learned from tons of unlabeled data, be it images or text or audio or whatever, and transfer that to different tasks. Usually a supervised task, we have only a minuscule or much smaller labeled data set. So we call this framework self-taught learning. Self-supervised learning, which I've talked about in other forums, has been an exciting piece of progress in self-taught learning. And I think the best example of this, the most exciting progress in this is in NLP. So you heard Łukasz talk just now, and the thing that really enabled this type of learning to take off was the work that Łukasz and his collaborators had done on the transformers. One thing I've learned about transformers work is that when you look carefully, you find that there is more than meets the eye. And that transformers work enabled the rise of other great pieces of work like BERT by Google and the various flavors of GPT by OpenAI. I actually just read the GPT-3 paper. Great work. And the lack of, and rather than using fine tuning, instead giving a text prompt to GPT-3 to have an additional output. I thought that was actually really, really interesting and clever. But if you haven't seen some of the demos of GPT-3 on the internet, it's worth searching around and finding some of the cool demos. But this is an example of English language correction. This is actually an example drawn from the GPT-3 paper. But I thought this was really exciting example of how this type of framework, we learn from a massive amounts of unlabeled data and then adapt it to some other task, maybe a supervised task, maybe something else. In the case of GPT-3, it's giving a text prompt and having it do autocomplete, right, to do these things. I think this will open up tons of applications. And I want to share just one last thought before I before I wrap up, which is just now Łukasz alluded to the early transformer networks, some of the machine translation models, the only stuff that you could do at Google back then. We've learned in tech that yesteryear's big giant supercomputer is tomorrow's cell phone wristwatch. And so all of these models, we'll see how long Moore's law holds up. Maybe it will, maybe it won't. But I think all of these things, and by the way, I remember early days when I was leading Google Brain. I remember we were so proud of ourselves that we got 16,000 CPU cores to train a giant neural network. And at that time, only Google could have done that probably. Today, any of you can go online to one of the cloud services, and for about $3,000 was my background about calculation. For about $3,000 worth of cloud credits, which isn't nothing, $3,000 is a lot of money. You could replicate what we were so proud of, doing slightly less than a decade ago. So all of these things that seem so incredible. When we work hard on improving these algorithms and finding the right applications, even if it seems niche, I just imagine one day where these models that we read about and are amazed by, I don't know if it'll ever run on your wristwatch, but this is how technology becomes more available. And right now, I see a lot of weak signals in the field of NLP from really building off Łukasz' and the team's transformative work. There's so many puns you can make with this stuff that I think will explode and become more capable and more widely available. And I hope that maybe you watching this from home, wherever you are, maybe by learning these tools, hopefully you can also participate in that revolution. Thank you.
Thanks, Andrew. I think that's really cool what you say about the future of NLP. There's some things you can think about as exciting advances that might be just on the horizon, but perhaps the most exciting thing is the unknown, the thing that nobody knows or nobody could predict. That's exciting to think about. So right now, I would like to continue the conversation by welcoming our other panelists. So today we have online with us Kenneth Church, Distinguished Scientist at Baidu USA, Marty Hurst, a professor in the School of Information and the Electrical Engineering and Computer Science Department at UC Berkeley, and Eunice Mori, an instructor of AI at Stanford University. So before we start the panel discussion, I thought it'd be good to just get a little bit of an intro to each of you. So Ken, if you could start us off, Ken Church from Baidu USA. Oh, it looks
I'm
like,
sorry.
oh, there you are.
Yeah. So you want an intro of?
Yeah, just an intro and a hello.
Hello. I'm Ken Church. I work at Baidu in California, but right now I'm in New York. Any rate, I've been working in the field since the 70s, mostly in computational linguistics, but also speech and language, and even things like data mining. Any rate, it's a real pleasure to be here.
All right, thanks, Ken. We're really glad to have you. Marty Hurst, could you give a little intro to yourself and your background?
Hi, everyone. My name is Marty Hurst. I'm a professor at UC Berkeley. Once, a long time ago, I was a grad student and worked with Ken Church. I visited him at Bell Labs. And I'm actually an interdisciplinary scholar, so NLP is one of my fields. Another field is human-computer interaction, or HCI, as well as information visualization and search. So I do focus on applications a lot of the time, although like Ken, I've been doing this since the late 80s, so I have done some foundational work at that time as well. And I really appreciate, I'm also very interested in accessible online education like Andrew, and so I applaud this kind of courseware that you all are offering here.
Great, thanks very much for the intro, Marty. Eunice Mori, could you give a little intro to yourself?
Thanks, Ryan. I'm Eunice, and I teach here at Stanford and also at deeplearning.ai. So you've probably already seen me at deeplearning.ai with Łukasz in the specialization. And I'm also very interested in accessible education, specifically for AI. and hope to see you all soon.
And I just say, really grateful to Ken, Marty, and Eunice, in addition to Łukasz, for being with us. I just want to give a shout out to Ken, who was a huge help to the whole team in creating the NLP specialization, in addition to being an insightful, leading figure of NLP. So thank you, Ken. And Marty, I've known for a long time, had the privilege of learning from her, interacting with her way back when I was a student at UC Berkeley. And Łukasz always worked with and known Łukasz for a long time. And Łukasz and I actually co-instruct one of Stanford's machine learning classes. So really glad to have all of you here, and Łukasz, of course, as well.
Great. Yeah, this group goes way back. So what I'd like to do now is, for the next 30 minutes or so, I'll be asking some questions of our panelists, and while I'll be directing my question to an individual one of you, I'd like to encourage anyone else to feel free to jump in and offer your own input on the conversation. We'll just kind of keep it rolling that way, and then we'll after that we'll be fielding some questions from the submissions that we're getting online. So Marty Hurst, I'd love to start off with you. As a professor, I'd imagine that you have students coming to you a lot asking what to focus on, or what to get into, or why to get into something like AI in general, or NLP. So what do you tell them?
Yeah, it's a great question. And we have both undergraduates and graduate students. And I also do talk to people that are looking at second careers, and I speak at panels as well. And that might be, I think a lot of your audience, it might fall into that group. So the first thing is, why are you considering this area? And I do find that people often do something because everybody else is, and that's often not a good reason. So really look carefully at what your motives are. Now, there's nothing wrong with dipping your toe in, and with these online courses, it's so wonderful that you can just get your feet wet, start to learn about something without a really big commitment, and learn a bit about it and see if it's for you. But I think really assess what interests you, what you like, and then see if something about that field resonates with you. In terms of other parts of AI, they're not really my specialization, but I can speak to NLP and what drew me and what's drawn other students that I've worked with. So I'm really interested in language. And I think that when I was in grad school in my first years, people in NLP, there were a lot of people that were linguists, or we were computational linguists. It was people interested in language, or interested in psychology, interested in the mind, interested in philosophy. I see that there, and I was interested in sort of animation and how do we make a computer interact with language. I mean, that was just really fascinating. And I think today, a lot of people are coming at it more from the machine learning angle and the mathematical angle, and that's a perfectly valid angle as well. And there's room in the field for both types of people, or all types of people. But I think that it's, again, look at what your interests are and see which part of the field is right for you. But even if you are currently strong on one side of this, one of these aspects, but not the other, don't let that deter you, because you can learn the other aspect. So people that start with machine learning but don't know a lot about language can learn. I would say that language is a very deep field. It's harder to learn than something like, not harder, but it takes more time than something like information retrieval. Just language and linguistics is very deep, very complex, very rich, but you can still get a first pass at it, but it rewards years and decades of study. It never loses its interest, I would say. And the machine learning side, some people have that background, some don't. You can learn it. There's so many great resources now, so different from when I was a student, that you can, with study and practice, learn those skills if you don't have them. But I'd say just the best thing about NLP is it's interdisciplinary. So it's not just the machine learning side, and there's applications that are fascinating, as Andrew so wonderfully outlined. And so if you're interested in applications, in changing the world and making a difference for good, then there's a lot here for you. And if you're a skeptic too, I mean, there's a lot to question about AI. And I think there's a lot that you can contribute from that angle in this field. It helps to be well informed about the technology if you want to look at it from a skeptical perspective.
Yeah, that's a really interesting point, that the field would definitely benefit from more skeptics and more folks challenging ideas. It's also interesting what you said about NLP or language. I know you worked on computational linguistics, but I think sometimes we make the mistake of thinking about NLP as just another application of machine learning, but it's really language meets machine learning, and language itself is a whole world unto itself. So that's an interesting thing to consider. I'd like to ask you a question, Ken Church. You've been in the field a long time. You've worked on a lot of different things. You've seen the academic perspectives, the industry perspectives. First, if you could just kind of paint a picture of where the field was when you got started in it and where it's come to today. I know that's a broad scope, but if you could give us some historical perspective, that'd be great. Sure,
I'd love to. So actually, let me go a little broader than you suggested. So I was at Harvard when Skinner was there. And in those days, empiricism was all the rage, not only in psychology, but Shannon was sort of at his peak then, information theory. Firth quoted this very famous quote, "You shall know a word by the company it keeps." Harris, who was Chomsky's professor, pushed the distribution hypothesis, the idea that you would understand what's going on by distributional statistics. All feels very familiar again today. Then 20 years later, I was at MIT when Chomsky and Minsky were there, and they were pushing a different position that was called rationalism. It was anything but the empiricism of the 50s. And then my generation, so what I want to say is that Chomsky and Minsky rebelled against their teachers. Turned the fate and against our teachers, Chomsky and Minsky. We revived empiricism. And it's hard to remember that before the 1990 or so, it was almost impossible to get a paper into a top conference that used statistics at all, right? And then 20 years later came along deep nets. So what I want to say is that every 20 years there's an oscillation. It goes back and forth, and I think the basic common theme is like that cliche about grandparents and grandchildren. They have a common enemy, that every generation needs to rebel against its teachers in order to make its mark. And I wrote a paper called "The Pendulum Swung Too Far," which sort of goes over this whole history. Anyway, in retrospect, maybe that's sort of unfortunate metaphor, that it's not really quite as simple as that. Chomsky was a strong personality. Minsky's actually a sweetheart deep down, although he never really warmed this guy. And I want to say that while we never agree with all our teachers on everything, we don't agree with everyone on everything, and it's perfectly fine to disagree. What I want to say is that a lot of times fads come, fads go, but a lot of these things have always been around in good times and bad times. Hinton and LeCun did what they did when it was fashionable and when it wasn't. And similarly, Salton, who's sort of the guy behind vector space, which is really like word2vec, and it's really the foundation behind much of what we do. That stuff was very unpopular through most of his career. So I want to say that we mostly have been talking about methods, empiricism, statistics, and so on. I think Marty did a pretty good job of talking about some that's important too. But it was very important. We didn't always have with data. Back in the 80s, it was very, very hard to come up with data. Nowadays, it's a lot easier. You can hope to get massive numbers of books and Wikipedia and all sorts of things. You can download these wonderful data sets. It wasn't so easy. But even so, we tend to underestimate the importance of things like balanced corpora. A data set should be a sample of something. We want to think about what the population is we're trying to sample. Not all data is interchangeable, and so on. The last thing I really want to highlight is the commercial impact. I no longer have to explain to people what I work on. There was a time when I had to explain what speech recognition is, what speech synthesis is. You've all experienced this now. there was a time when there really weren't any commercial successes. You probably heard of the company Semantic, but you probably don't know why it's called Semantic. It's in our area, but it wasn't success. Any rate, nowadays there are lots of Fortune 500 companies in this area. I no longer really have to, we don't have to talk about just supply. There is tons of demand for what we do. That's all new. That wasn't like that in the 50s, certainly not even in the 60s and 70s or 80s or 90s. Anyway, thank you.
That's fantastic, that perspective. Yeah, working on things when they're not in demand yet, but now for sure, there's no question about whether this stuff is relevant or whether it's going to change the world. That's very interesting. Łukasz, I'd like to ask you a question. We talked a little bit, or you talked about transformers a little bit, and Andrew touched on it a bit in his talk as well. A few years back, the paper you wrote or co-authored with folks called "Attention is All You Need," and we've already had some good puns on this, but this paper's gotten a lot of attention, if you will, and the subsequent things that have come out based on transformers have been really exciting. I think for the audience that we have gathered today, I think many of whom might be familiar with the sort of math and basic architectures around neural networks, how would you explain what is the transformer and what it was designed to achieve?
Well, I think it's good to bring back to what Ken said. Everything comes in waves, and everything builds on top of the things that were before. You need to understand the context before transformer, which is where everything was, at least in the deep learning part of NLP, RNNs were doing everything, right? They were the big first wave of deep learning NLP, and they have this super basic idea that you should do things in recurrence, step-by-step process, right? Which is so intuitive, but it's really slow on modern hardware because the accelerators are built for parallel processing. So the idea of attention comes from another very old technique in NLP, which is alignment. When you try to translate sentences, you have an English one, you have a French one, you try to align which words correspond to which words. So if you put this alignment idea into a neural network, what you get is the attention mechanism. It is a soft version, a differentiable version of aligning words with words that come before. And self-attention is aligning the same text such that you align with words that appeared earlier. And this idea works surprisingly well in terms of the results you get, but it also works surprisingly fast if you implement it well on modern deep learning accelerators. So it's a mixture of making the implementation really easy to use, and I think that was part of why it became so successful, because you can just run it and it runs fast enough. It's always a big difference whether you need to wait for your result 1 day or 1 month. But the other thing is alignment is a really good idea. This has been known in NLP for a long time. If you want to translate a whole paragraph, it's much easier when you focus on translating this part and only look at this one part at a time. That's what every human being does. And you give this prior to a neural network, and it works really well. So that's where attention came from. But I would want to say that as everything goes in waves, it's a very good idea to use RNNs, because there are modern papers on sparse transformers that kind of start showing that this attention is more like RNNs than people think, and actually adding some recurrent networks into it makes it even better. So it wouldn't be surprising if people go back to recurrent networks in some way of fashion again. That's why it's good to learn about more than just the most recent technique. It's good to know things that came before and learn all about it.
That's really interesting. That in some sense, with the development, pushing the boundaries of transformers, that you end up kind of somewhat circling back to where you came from. Yeah, it again highlights that the building blocks are important, or that where it came from is important. Eunice, I'd like to ask you a question. you're the sort of earliest career panelist here, and I think it must be an interesting perspective to have been studying all this stuff or sort of developing your own mastery while the field was advancing so fast, or while it was sort of making such a big public splash. So maybe you could give some perspective on what your journey's been like, and also any recommendations you'd have for people who are wanting to potentially start on that journey themselves.
Yeah, thanks, Ryan. So my journey has been a little bit different. So for me, education means a lot to me. And especially I grew up in Morocco, so we do not have access to the latest, technologies and states of the art and as many resources as we have here at Stanford. So for me, I really wanted to be part of the mission that will help, take the latest technologies and states of the art and make it accessible to everyone around the world. So that's how I started. And I came here around in 2014, where I started with the machine learning course on Coursera. And I started by writing like lecture notes and trying to make it as accessible as possible to everyone. And eventually I started building up and, studied math, computer science, statistics, and just started slowly, mastering, building assignments and quizzes and so forth. So that was pretty much the journey. Then we built the deep learning specialization, and we started teaching on Stanford campus. So it's been interesting because every time you finish building an assignment, then there's a new technology that goes out, and then you have to read another paper and then try to transform it into another assignment, and it just keeps going on and on. So it's been definitely exciting to be like, as soon as you're done with a new assignment, you go ahead and try to bring in new states of the art. So, yeah.
I can definitely say from my own perspective that working on these courses with you and Łukasz has been really interesting in the fact that the field has developed significantly while building the courses. So that feels like it's been an exciting path. Andrew, I'd like to turn to you with another question. So, as you mentioned, you worked on a wide range of AI applications. I think that one of the issues that you've also thought about is that the fact that AI often seems like a black box, and people struggle with explainability, or at least there's skepticism around the sort of black box nature of AI algorithms, and particularly the bias that might come out of algorithms when they're when the output's not fully understood. So in the field of NLP, what thoughts do you have on how models can, or how we can think about bias and what the big considerations are?
Boy, don't know. This is a tough one. I think that I've seen a few pieces of very good work. Right? One of the most influential papers of recent memory was the one out of Microsoft showing the bias in learned word embeddings, where if you learn from text off the internet, learns the really horrible analogy that was it man is the software engineer, or man is the computer programmer, as women into the horrible output, a homemaker or something like that. And to the Microsoft team's credit, they proposed a solution to zero out this form of bias so that you end up with the more appropriate conclusion, which is man is to computer programmer as woman is to computer programmer, which seems like a much more appropriate way of mapping analogies. I think explainability and understandability is one of those things that speaks to the importance of the field, right? Once upon a time, the field of AI, frankly, the field of computer science had much less of an impact than, and it was just a few people writing software, doing cool things, trying to build things that work. But today, the work of the entire discipline, computing, AI, NLP, has such an outsized impact. that we owe it to society really to think through the real impact of our work and then to do our best to move things in a positive direction. And I think, you know, there's one, when Ken and Łukasz were speaking, there was one thing that occurred to me that I want to comment on, which is Ken mentioned, and Łukasz mentioned also technology coming in waves, and Ken used the term fads in NLP, which I think is completely accurate. One lesson I've learned thinking a lot about technology is I think it's important to time the technology appropriately. And so, you know, who invented the helicopter? You know, that thing that flies around, right? It turns out Leonardo da Vinci had early drawings of what looks a lot like a helicopter. There were some problems with Leonardo da Vinci's designs. He did not get it right. But if you search online, you find Leonardo da Vinci was trying to invent a helicopter. Totally did not work. Without the internal combustion engine, the human body could not generate enough power for its contraption to lift off in the air, so it failed. How about smartphones? Well, the Apple Newton, search online if you want, the Apple Newton was a terrible idea. Technology wasn't ready. LCD screens weren't ready. Batteries weren't ready. The touch interface wasn't ready. So the Apple Newton failed. A couple decades later, Steve Jobs, you know, launched the iPhone, and that transformed the world of mobile computing. So I think a lot of the fads that Ken accurately alluded to is about getting the timing right. In my opinion, and this may be controversial, 30 years ago, deep learning was a terrible idea. Computers weren't fast enough. The data wasn't there. It just didn't work. Now, I'm not ungrateful to people that were working on deep learning 30 years ago. I think, you know, they laid the foundation. And you can also argue, maybe I actually have no idea if Leonardo da Vinci's early drawings of helicopters inspired whatever actually happened about 50 years ago or something. Actually, maybe more than 50 years ago when it became practical. And even though Apple Newton failed, you could argue maybe it laid the foundation for the modern smartphone. So I'm not dismissing the importance of the early foundational work. But I think 30 years ago, 20, the timing was wrong. And the right timing to jump into deep learning was maybe 15 years ago, when finally the compute became powerful enough and the data became there, and then deep learning kind of finally overtook, you know, support vector machines or whatever we're doing a little bit before then. So really, Leonardo da Vinci deserves tons of credit for envisioning the helicopter, even though his attempts to do it failed. But I think as we go through these things, I think the timing of NLP, it feels more solid now that, you know, the computer's there, the data is there, we're getting early nascent results. And, you know, one of the ways to have an impact on the world, not the only one, we need people working on all sorts of things, including things that are like 50 years out, or including things that are 100 years out. It's fine. You know, we need people working on all sorts of things. But if you look at the weak signals, I think one of the best ways to make a big contribution to society is if you can spot the weak signals about things that, with our help, can take off in a better way or a faster way over the next several years. And to me, NLP pattern matches very well to you can see a lot of the weak signals that suggest that if you work on it, you can make a big difference. Whereas arguably, I think maybe Leonardo da Vinci did have a big impact on the rise of helicopters. I actually don't know. And certainly the pioneers 30 years ago had a big impact on the work today. But given that we all have limited lives and limited amounts of time, I want to do the work where I had kind of the biggest impact. And so I try to think through, if I do this now versus don't do this now, what enables me to hopefully help others the most. And I do think NLP pattern matches well to that. Yeah. And I don't know, and I know actually, Marty, I know you thought a lot about timing too. I don't know if Ryan wants us to jump in chaotically.
Yeah, I do. Actually, I think that I was going to follow up there, but Marty, I would love to get your perspective on timing, because yeah, I think I've also I guess there's one way to think about it, like if you want to time something right, you should be ahead of the wave, and so like if it's a big deal now, maybe it's too late and you should move on to the next thing. But it sounds like for NLP at least, even though it seems like a really big deal right now, it's perhaps just the beginning or something like that. But Marty, I'd love to get your perspective.
Well, first, I loved Andrew's analogy to Da Vinci and the helicopter and neural nets not being ready. When I was a grad student, people were tinkering around with it and hoping to make it work. Actually, a lot of people I know got interested in AI, got sucked into neural nets, and it kind of was good. They were productive, but it wasn't really going anywhere then. And so just being the wrong timing and linking that to something seeming like a fad, as opposed to, oh, it's having its moment because it's possible. That said, there's a lot of things that become fads that are just popular because there's something that interests people, and even though they're clearly not working. So I think that does happen as well. And I can think of examples that I won't name. But in terms of sort of timing and in terms of choosing research projects, and I know this is an audience, I think maybe largely of practitioners, so I don't know how much it applies to people in the audience here, but for those who are thinking about research, my strategy, or I guess I couldn't call it a strategy, but my bent was always to look at an area where there weren't a lot of people working, or look at a problem where people weren't that interested in it. Like I was looking at search before the web. So it was, to say it was unpopular is an understatement. It was very much a backwater. But I was really interested in the question. I just didn't like library catalogs. I wanted to fix them since I was a kid. And so that's why I was interested in that topic. And I had ideas about it since I was a kid, and now they are what you see on websites when you shop now. So that's very satisfying for me. So a lot of times there's a problem that you want fixed and nobody else is thinking about it. So maybe you can fix it. Or maybe a few people are thinking about it, but you have a slightly better way of doing it. So for me, that's what I started with. It's what are you interested in? Not as what is everybody else interested in. If you really want to have satisfaction in an intellectual pursuit, I think that's the most important thing to think about. And then if you want to pursue something that other people aren't doing, be prepared for a lot of rejection. Be prepared for your papers to be rejected. I have a lot of well-cited papers. Most of them were rejected the first time I submitted. I often had to send them to a smaller venue or something, and then they're kind of cited strangely. A few of them were accepted the first time, but that happens to almost everyone who has a new big idea. Their papers are rejected the first time. If it's a good idea, just keep working on it. So yeah, everyone has their own way of working. Some people are really good at taking ideas that are established, but making them deeper, making them more sound. And that's a great way to advance work as well. It's just so important to understand what are your particular interests and strengths, and do that, and not what everyone else is doing for that sake.
Yeah, absolutely. Ken, I wanted to get your perspective as well on the timing of things. I know you've probably seen a lot of different things timed well or timed poorly, and
Yeah.
What would you say?
So I think of timing a little bit like a stock market. You want to buy low and sell high, and not vice versa. And a tendency is to do just the wrong thing. That is, it's sort of like a kid's soccer game where everybody goes to the ball. It's much better to play your position and to get a good assist. And in my own case, I was very early on for the revival of empiricism in the 90s. My first empirical paper was in the late 80s. People have been looking at it. In those days, maybe there were hardly any papers in empirical methods. A decade later, there were hardly any papers in anything but empiricism. So it's good to get started in the 90s, and by a decade later, it's time to do something else. Deep nets came in a pretty good time. I would worry about jumping in when everybody else is jumping in and doing what everyone else is doing. You want to get into the next new thing. And I don't know what that is, but I think we could make some suggestions. I don't think it's a good idea to be doing what everyone else is doing. And Marty, I think, put that very well. Thank you.
Yeah, I think the audience would certainly welcome suggestions if anyone has them. I know that it's hard to predict what the thing will be, but
so maybe I can jump in with one comment on that. I feel like it might feel with the internet like everyone is doing deep learning in NLP. I feel like it's actually the opposite. I think this is a field that has barely scratched the surface. Of course, nowadays everything happens online. It feels like if you submerge into a field, it feels like there is a lot of movement because the world of NLP is much bigger than it was decades ago. But I feel we are barely scratching the surface in what these deep models can actually do to language. And this is, as Marty says, language is an extremely deep field where yes, we can generate you a story and it reads okay, but does it really have meaning? Does it really can we really steer this to generate things that are true? Can we verify? Can it tell us, we talked about biases. You can actually ask the language model, is this offensive? And in a lot of cases, it will tell you whether it is or not, but it will make some mistakes that are very non-human-like. Can we understand why? I feel like with the GPT-3, which was only released weeks ago, it's the first model that shows that you can do learning without gradient descent. You can just put things into the model as input, and it works as if it was training on them. So this is very new, and it's very hard to test because you need large models. So I feel like in half a year, in a year, there will be models that you'll be able to start doing this with hands-on. So that's why I feel like it is a great time to start learning, because it's only beginning a lot of these things that actually go into language. I feel like we've gotten the technology, we've gotten the connection to deep learning, but actually going into the depths of language is still ahead of us very much, and this will bring applications. I think maybe Marty can say more about that.
Yeah, I think you're making a great point, Łukasz, and I don't want to imply that people should stop doing deep learning. I think that's a fundamental tool now. So one works with the fundamental tools of the field and moves forward. And I didn't want to imply otherwise in case I was. I think that the key thing though is, like you just raised GPT-3. So I think a lot of people are having reaction to language modeling as being the way, now we're getting a little technical here, but being the way to solve all the problems. And so people are looking for alternatives to that, since it's clearly not going to solve, well, I think it's not going to solve a lot of the hard problems. It doesn't model a lot of things about language and communication that are really important. And by the way, for an area for people to think about going into that Andrew mentioned chatbots, for example, which are sort of a type of communication. We really don't know how to do communication well with language or interaction. That is really unsolved. And it's an intersection of a lot of interesting fields. We really don't, our machines do not read, despite that word. There's no understanding in these systems, I don't think. And so we're doing really well on applications that we did terribly on. 10 years ago, I used to open one of my classes with scenes from 2001: A Space Odyssey and have the students say what's possible and what's not. And I don't even do that anymore because they're almost all possible now, but except for the very end of the movie. But nonetheless, it's somewhat of a mirage or an illusion in terms of what's going on with NLP. And so instead of just working on, what I mean is don't just work on language modeling, work on these other more difficult problems, which I think is exactly what Łukasz is saying.
Absolutely. Yeah, that's interesting perspective. Ken, did you have something you wanted to add to that?
Yeah, so I certainly agree. There's tons of interesting open problems in language and deep learning, and I don't want to discourage anyone from that. What I'm more worried about is that there are a lot of papers these days on sort of mindless benchmarks, and I've got an opinion piece coming out soon called Benchmarks and Goals, where I'm saying we should focus on the goals. What are we trying to address here? And I worry that some of the benchmarks take on a life of their own, that they were posed for no particularly good reason. They might have once made sense, but they certainly don't make sense now. And suddenly you see an enormous number of papers showing incremental progress on something that's not worth doing. And that worries me. Okay, so I think of consensus here, there are a lot of things worth doing, but that's not one of them.
Absolutely. Yeah, I think that it can seem like that sometimes, that there's just endless plots showing the number moving slowly higher and higher.
Well, untested are not worth doing.
Untested or not.
Can I say, on one hand, Ken, I agree. On the other hand, I think to a lot of people, I think it's okay. So there are a lot of online programming competitions, or some of the machine learning modeling competitions. I think at some point, they are pointless, but I think to a lot of people it's an important learning experience. So when I was learning, actually, I am still learning AI myself, but in my phases of learning journey, I do a lot of pointless things, right? Write a lot of code with no purpose other than I want to try this thing out and see what happens. And I think it's actually okay. I was talking to someone in a large travel company that had built a chatbot, and their executives were saying, "Hey, this is useless. How's this helping this big this very large travel company? How is this helping the company make money?" And I think they said, no, it doesn't help the company make money at all. But I think that's fine, because to this team in this very large company that I think you probably have heard of, I'm not going to say their name, it was an important part of the learning journey of the AI team to try these things out, do a little demo, and to go. Now, if they stay at that level for their whole life, then that's not great. But as a stepping stone to then do something bigger and more significant, I think it's fine. So I think really to anyone, go ahead, download some silly thing, build some silly thing, download tweets and classify things the way that's totally useless. If that's all you do your whole life, maybe that's not so great, but it's a stepping stone to gain skills to then go on to the next level. I think that's fine. So I think if Ken's complaining about people doing this their whole life, then I'm with you. And I also encourage people, as part of your learning journey, go ahead and do a fun but useless project. Right? It's fine. And then celebrate that. And then use the skills you learned to do something even bigger.
Absolutely. Great perspectives. Eunice, I wanted to give you a chance to add to the conversation. It looks like you're on mute, though.
Yeah, thank you. So one other trend I've been seeing is that these NLP models have been getting larger and larger. So like GPT-2, then GPT-3, and then I don't know, GPT-4. I don't know what's going to come up next. But the thing is, one other important research application I'm getting interested in is, what if you can just take like these huge models and make them smaller and keep the same performance, so you can load it in an app, and then it could be way more useful than having to like log into a server and calling the API. So model reduction, I was thinking, would also be a great research.
Absolutely. All right, at this point, I would like to turn to some of the questions that have been coming in online. We have a lot of people asking questions, and hopefully we can cover a few of them here. I think one thing that is on people's mind, we touched on it a little bit, but the question of GPT-3 and, okay, what does this mean? Does this mean everything else is now irrelevant and that it doesn't matter anymore? This is the thing that everybody's going to use, and so whatever all the other stuff was, don't bother. Just think about this and the next thing. Maybe Łukasz, you could start us off on some thoughts.
So GPT-3 is a big transformer. We will actually go through the whole code of, you'll understand every line of this model in course 4. It's a transformer model trained on all of the web. It predicts the next word. And it's wonderful that it generalizes with Future of Learning to new tasks, which is a little unexpected, but it has really been trained on all of the web. So it's not that unexpected in some sense. And you will see even the smaller models we'll train in the course, sorry, they do generalize as well. So now the GPT-3, it gives you answers, great. But as Marty said, what use are these answers? And maybe your tasks fits this is the question, this is the answer paradigm, but you need to solve, usually you want to use the model to solve your task. And if you play with it, it's okay, you should solve a useless task, get experience, you should learn. But later you need to use a tool in a real world task. And as I told you, we have great translation models. Google Translate is not just this model. You cannot launch a deep learning model just like this. You need to put some regexp, you need to put some pre-processing, you need to put some post-processing. All of the old techniques that even just simple regexp to see if it's producing some terrible output. You need that. You need to really look at what you're outputting to your customers, to your users. And you need to verify it, and you need to start thinking, why is this model in certain situation producing such a bad outputs. And if you don't know how to repair the model, and there is still a lot we don't know, then you need to put some defenses against this. Maybe just detect cases when the model is really bad. And GPT-3 is bad in many cases. It's good in many other cases. So you just need to learn. It's a tool. You need to really learn how to use it, gain experience on maybe some useless problems, gain experience everywhere you can, because you can use it productively, but it's not just take it and apply it and it works. No, it's a lot of work to understand when it works, how it works. And as Marty says, hopefully with the years, we'll get a better understanding of how these things actually work. They're tools that allow us to go a little bit deeper in language, but there's still a long way to go. And I think the courses will help you get a real understanding of where can I use it, or where maybe, but there might be a lot of other things that are needed too. And there will certainly be a GPT-4. It's not the end of the road, but it's a great step on the road. Yes.
Fantastic. Thanks for that perspective, Łukasz. We have another question here, and I guess I'd like to direct this to you, Marty. But if it feels like I feel like you've touched on a lot of things that are probably related to this, although I don't know everything about your background. The question is, can you tell us about the influences of cognitive science and neurobiology on neural network architectures? So, for example, computer vision architectures have been motivated by local receptive fields and compositionality in the neurovisual pathway. Can you say something about that?
I'm not sure I'm the biggest expert on that in the cognitive science on neural architectures. Maybe others in this group know more and they can indicate that. Certainly, though, I can say that it had a lot of influence on NLP in the earlier days. And there's a classic, the Rumelhart-McClellan book, Rumelhart and forgetting the second name, McClellan?
No.
Yeah. I remember, okay, McClellan, where actually that was a very early neural net books on distributed cognition, and they really were motivated by cognition and modeling language and thought. And those are great classics to look at. They're a little hard to read, but if you're really interested in that, those are the books to look at. But maybe other people can answer too.
Maybe I'll say, once upon a time, a lot of neural networks was inspired, motivated by neuroscience. I remember, again, maybe about 10, 15 years ago, there was actually a bunch of us. I remember I read a whole stack of neuroscience papers about 12, 13 years ago, looking for inspiration for new deep learning architectures. So I think there has been an element of inspiration. And ideas like sparse coding, right, which I still think is a good idea, purely really inspired by neuroscientists like Berkeley's Bruno Holzhausen, for example. But I think the trend recently has been that AI deep learning has evolved into a standalone engineering discipline where the principles by which we get ideas how to move the field forward tend to be engineering computer science principles. And I think the inspiration from cognitive science and neuroscience has diminished significantly over the last decade. Not saying it's a bad idea, not saying people shouldn't try it, but if I look at the percentage of new ideas that seem to be going to deep learning, the percentage that seems to have its roots in biology seems to have significantly diminished in the last decade.
Thanks, Andrew. We have another question specifically for Ken. Do you think that the latest cutting-edge NLP techniques, like transformer applications, could be applied on all text formats and styles? So, for example, could you do something like neural style transfer, as has been shown on paintings, to be to do some work with writing styles? Seems like this is something that people have already tried working on, but Ken, could you comment on that?
Yeah. So, I'm sure that this is a topic that's there's probably already some papers on arXiv that I don't know about that address this. I mean, it's just unbelievable what's going on. That said, I do by it. Not that I have anything bad to say about transformers, but I think that just based on the history that I talked about, if you ask me, how long do you expect transformers to stay on top? I'd say I'd be shocked if they stayed on top for more than a decade. Probably not that long. You know, how long did LSTM stay on top? It wasn't that long. How long did any shiny object stay on top? It's just not that long. So we could start to say, what are some challenges? What are some of the big, hairy, deep, open problems that have been open for 60 years that maybe, you know, transformers have something to say about? Like, say, Chomsky talked about long distance dependencies. He was criticizing Shannon and n-grams, where the distance, what he thought by long distance was something that was shorter than a sentence. Now transformers can deal with something that's longer than a sentence, but I don't know if they can really deal with something the size of a book. Something like that. So large scales is one of many things. Robustness is another one. So in the 1962 DARPA mission statement for what is the funding agency supposed to work on, robustness was in the mission statement. And I'd say it's still a kind of work in progress. The ACL Best Paper Award this year was on that topic. And we normally deal with average case performance. All the numbers you heard were about average case. Occasionally we talk about worst case adversarial GANs, but I want to say what this Best Paper Award suggested is that we should work on something that's harder than average case, but not as hard as worst case. Something like, what would a reasonable user expect the system to do? That's probably, you know, I worked for a company once that tried to do 5 nines reliability, defects per million. That's very expensive. That's not as expensive as the worst case, but it's very expensive. Other companies, it should work. A user would be okay with a couple of defects. Now, what I want to say is that these kinds of things, the neural nets right now are still kind of trained for average case. So the kinds of things that people are asking, what can this not do? You know, we're all saying, well, can this do this? Can this do that? Can this do the other thing? We did used to worry about not only what we can do, but what we can't do. Say, like, you can't compute all functions. You can't solve the halting problem. You can't do decidability. There are many things like this that we can't do. What is the next opportunity for the next shiny object to do? There's probably going to be something that's going to be better than transformers. Right now, transformers look really good, but that's right now. Anyway, thank you.
Thanks, Ken. Would like to close out the session here with
for 5 minutes. Because, as Ken said, this was a problem very much on our mind. I mean, Transformers was 3 years ago. We've been working these 3 years exactly on that. Like, Transformers are not the end of the road, right? They're a step. There are new models, and one paper we had just this year is the first transformer that can actually do a book, which I will tell you a little bit about in the last course. It's called Reformer. And it also will not be the last step on the road. That's why you need to learn how these things work. So in a year, there will be a next step, and you'll be able to use whatever comes, whatever's needed for your application. Yeah, that's why learning is so powerful, because it's never the end.
Fantastic, thanks, Łukasz. I'd like to close out with one last question for Marty. Someone asked, given that the field is changing so rapidly, we've just been talking about some of these changes and like how even the stuff that seems exciting right now might not be exciting even a few years down the road. Does it make sense to dive deep into particular topics like solving a particular problem such as speech recognition, or does it make sense to sort of stay diverse, try to learn about everything, try to get a sense of everything? What would you tell to somebody heading into this field, Marty?
Well, I always tailor my advice to the individual, so it's hard to generalize, but I will say that the statistics that Andrew presented about the number of papers being submitted and the amount of work going on, increasing exponentially, has made this field, the field is different than it ever has been in my life. And I think this is how the biosciences are, where developments are extremely rapid, but it's new. And I think we're all trying to figure out how to navigate these waters. I don't think if someone says they figured it out, they're probably lying. So even graduate students who do nothing else but read these papers and work on them can't keep up. So imagine what it's like for someone like a professor who has to do a lot of committee work and be in multiple fields. So the fact that you all who are spending full time teaching these classes, and when there's a new paper have to make a new lesson, I mean, that's not sustainable for a faculty member. So it's kind of a crazy time, and I don't have a solution for how to keep up with everything going on in the field right now. People, what they're doing is they're putting their head down, they're picking a problem, they're learning what they can about some subset of techniques, and also by talking to others. And they are looking for solutions within a subspace of all of the possible solutions. And at least that's what my interpretation. I'd love to hear other people's views on this. But you have to get the foundations first. So if you're new to the area, you've got to take the courses. You've got to get the broad foundations on the language side, on the machine learning side, on the programming side. You've got to get a lot. The courses that give you like examples to start with, where you write some code, test it on a test set, like Andrew said, are incredibly valuable for letting you learn how to do things. And then you have to just keep learning and studying. I mean, I was actually yesterday taking an online course to actually finally learn GitHub. I'm just gonna admit it, I hadn't learned it yet. It's my 4th version control system, so I was tired of learning version control systems. We get tired of this, we always have to learn new ones, but that's part of this field. Even the professors, we have to constantly learn these new tools. So bottom line is, get broad first. It's a T. Get broad first. Go deep, but it's a T with multiple. It's not really a T, because I think you have to go deep multiple places. But I'd love to know how other people are coping with this growth.
Cool. Well, I feel like we could keep the conversation going for a long time here, but we need to save some time at the end here for the course demo with Eunice. So at this point, I want to thank all of the panelists very much for all the insights. I want to just mention as well that for people looking to stay up to date, we do publish a weekly newsletter called The Batch, and that we spend a lot of time trying to figure out what's relevant to think about this week, and sort of bring it down to a consumable size so that you can try to stay up to date. Of course, we can only do so much in there, but it's a great place to catch up on some things. Thank you very much to all of the panelists, and at this point, Eunice, I'd like to turn it over to you to give us a little demo, a little sneak peek into the course that's coming out today.
Yes, thank you, Ryan. Let me just, great, perfect. I hope everyone can see my screen now. Okay, so what I'm about to do right now, I'm gonna give you a course demo of course 3. And so why take this specialization? The specialization teaches NLP, which is one of the most sought after skills in AI. And you use NLP every day. So text is everywhere, basically. Right now, you're reading text when you are looking at your phone, you're using text. When you're sending a message to someone, you're using autocorrect. When you're inputting a search query, it's Google search, you're using autocomplete. You're basically using Google machine translation every time. You're basically using NLP tools and applications all the time. So why take specifically this specialization? Well, the specialization was designed specifically to build up to the latest state-of-the-art models. So you start with course 1 and 2, where we lay the foundations. And then in courses 3 and 4, you start reaching state-of-the-art. And hopefully by the end, you'll not only know how these APIs work, but also you'll be able to use them. So you'll know how they're built from scratch and how to use them. So who is this specialization for? First of all, the prereqs for the specialization are just basic machine learning and basic coding. So as long as you know basic machine learning and some basic coding, you'll be able to do the specialization. Software engineers, developers, and students of all backgrounds can easily take the specialization. And if you're a product manager, entrepreneurs, and digital businesses who want to transform their businesses into AI-powered businesses, then this specialization will also help you with that. And also people who just want to know the latest AI trends. Currently in the specialization, we do cover the latest state-of-the-art models. So it will also be a very good thing if you just wanted to know what the latest industry is using. So let's take a look at what you learn. This is just a recap of course 1, where you learn to do sentiment analysis with logistic regression and naive Bayes. And then you also learn about vector space models, PCA, and locality sensitive hashing. So you learn how to translate like one word from English to French, or you learn how to complete analogies. So this is course 1, and it does lay the foundations. Then in course 2, you learn about dynamic programming and hidden Markov models. So this is where you learn to build these applications like autocorrect, autocomplete, and then part of speech tagging. For example, if someone told you book of flies, then book is a verb. And if someone told you I want to read a book, then book is a noun. So this is also useful and has a lot of consumer enterprise use cases. Course 3 is where we start getting into more deep learning, and where you cover like dense and recurrent neural networks, LSTMs, GRUs, and Siamese networks. For example, we always answer, like sometimes questions gets answered, students ask us questions, and the same question gets asked again and again. So with a system like with Siamese networks, you can identify whether a user asked the question that has already been answered, and you can just recommend that answer to the user. You also learn about text generation, named entity recognition, and how to identify these question duplicates. And this is course 3, which is currently state of the art, where you cover encoder, decoder, causal, and self-attention, where you perform the latest state of the art machine translation. You learn how to take an article and summarize it. You do question answering, and you do chatbots. So you're not only like using an API. What's really special about this course 4 is that you do get to see how these products are being built from scratch, so you can use them in your own application and projects. And some of the models covered are T5, BERT, transformer, reformer. Reformer is the efficient transformer. So that's what Łukasz was talking about. And this allows you to save a lot of memory, and it just makes it much, much faster and allows you to capture long sequences. And then we also, by taking course 4 later, you'll also learn how GPT-2 and GPT-3, like they're just bigger models and bigger versions of themselves. So this is coming soon, coming in September. So stay tuned for that. But now let's focus on course 3, which is sequence models. So remember, course 1 was classification vector spaces, probabilistic models. Course 3 is sequence, and course 4 is the attention models. So in week 1 of course 3, you're going to do sentiment analysis. And I know you're like, oh, we've already seen sentiment analysis in course 1. But in course 1, if you had 2 inputs, like I'm happy and I'm sad, this is easy to classify. You can do a logistic regression, a naive Bayes, as you will see, or you've already seen in course 1, and you can get it to work. But what if I asked you a question, like an input, like with the grade setting, I almost like the movie, but things changed when I saw the end. So over here you have great, you have like, and then with a naive model, you might easily classify, oh, it's a happy sentence, but it turns out that it might be a sad sentence. So this is much harder. And this is what you do in the first programming assignment. So over here you have, it's such a nice day, think I'll be taking Sid and Ramsgate fish and chips. Anyways, it's like a positive sentence. And you can see that the model says that it's positive, but it's naive, it's simple. Over here you have, I hated my day, it was the worst, I'm so sad. This is obviously a negative sentence. But over here, with the grade setting, I almost liked the movie, but things changed when I saw the end. So you can see over here, you have the word like great, and then you have the word liked. So, but the neural network was capable of capturing this dependency, and it turns out that it is truly a negative sentence. So you'll be able to capture, you'll basically be able to build things that will be able to capture these dependencies. Week 2 is text generation. And what you'll do is you'll use character level generation, and you use a similar concepts in other text generation applications. So like poems, question answering, and chatbots all make use of text generation. And this is an example of character generation. So you can see here, and which thou hearst and bang. So it was generated 1 character at a time. And then over here, some more character generation examples. And all of these are examples that you will be building in your programming assignments of week 2 of course 3. Week 3 is named entity recognition. And this is an example, like many French citizens are going to Morocco for Christmas. And you can see I put Morocco and French, when French is geopolitical entity, Morocco is a geographic entity, and Christmas is a time indicator. So you'll be doing exactly this in week 3. And here's a concrete use case. Here's a concrete use case. So let's say that you want to help businesses with customer support tickets by getting structured data from unstructured data. So you can use named entity recognition to help identify people, places, brands, monetary values, and more. This is an example of a sentence. So Peter Navarro, the White House Director of Trade and Manufacturing Policy of US, said in an interview on Sunday morning that the White House was working to prepare for the possibility of a second wave of the coronavirus in the fall, though he said it wouldn't necessarily come. So you can see Peter Navarro is a person, White House is an organization, Sunday morning is a time indicator, White House is an organization, and coronavirus fall is a time indicator. So you'll also be building this. Week 4 is question duplicates. So I'm once again asking the same question, and you'll be using Siamese networks applied to a specific use case with the Quora dataset, and you'll use it to find similar search queries or similar sentences. And this is a very important application because you do not want to be answering the same question again and again. So this is an example of the programming assignment towards the end. And of course, over here, we're giving you like the built version, but you're going to build it from, you're going to have to code it. So the question 1 says, do they enjoy eating the dessert? And question 2, do they like hiking in the desert? So you can see that these are not the same, right? So it's false. Next, if you were to change hiking in with do they like the desert, and do they enjoy eating the dessert, then this will also be false. Now I'm going to add an S here, and you're going to see that these are still not the same because I can enjoy, for example, eating something. I can like something like kale because it's healthy, but I might not enjoy eating kale. So it's also false. But if you were to change it like this, then you get it's true. Do they enjoy eating the dessert, and do they like eating the dessert? Then it gives you true. So this is just an example of week 4 and the programming assignments that you will be building. And in conclusion, so we designed the specialization to not only show you how to use APIs, but also how to build them from scratch. And most assignments could be turned into products for consumer enterprise. And assignments are strategically designed to build up to the state of the art, like GPT-3, which is currently state of the art. And you just now have the tools and all the necessary equipment to start building any products that you want. Hopefully turn your ideas into a fully fleshed out product. And thank you.
Thanks very much, Eunice. Fantastic intro to the courses. With that, we are going to wrap up this event. And so if you'd like to learn more about the specialization that Eunice was just talking about, you can check out the link in the description below. We'll have course 4 that Eunice talked about launching in September. And we'll be sending a follow-up email to everyone who attended today. And we'd love to hear about how we can make future events better. So we're offering a 50% discount code to any of our online courses for up to 200 people, the first 200 people who submit qualifying responses. So keep an eye out for that email and make sure to send in your feedback. And as we mentioned before, if you're looking to stay up to date on NLP topics, check out the batch newsletter from deeplearning.ai. And thanks again to all the panelists who joined us today. To everyone else, keep learning and stay safe. We'll see you next time.